Hi everybody, Ms. Lee here. Today we're going to be talking about relative extrema. So that's relative extrema. We talked about this a little bit before, and so y'all should know the general look of relative extrema, but I wanted to give you a more formal definition of it. For relative, we're going to start with a minimum. So relative, relative minimum, the plural form of that is relative minima. That's going to look something like this. So this would be the relative minimum of this function. And we talked about this before because relative to the points around it, it is a minimum. So that doesn't mean that it's the lowest point on the graph. It just means it's the lowest point relative to the points around it. So this is a relative minimum. And if you'll notice, this graph is decreasing over here and then increasing over here. Okay, so relative minima occur when f prime of x switch from negative to positive, because that's where the graph changes from decreasing to increasing. So where f of x switches from decreasing to increasing, we have our relative minimum. So again, relative minimum is where f of x switches from decreasing to increasing, or where f prime of x switches from negative to positive. I'm sure you can figure out then what relative maximums look like, or relative maxima. So again, if you had a graph that looked vaguely like this, your relative maximum occurs right here at the top of a hill. So it's relative to the points around it, it is a maximum. So relative to the points around this on f of x, it is a maximum. And this area we're decreasing. And this area we're increasing. So that means that relative maxima occur where f of x switches from increasing to decreasing, or where f prime of x switches from positive to negative. So f of x switches from increasing to decreasing, and when f of x is increasing, f prime of x is positive. And so we're going to say f prime of x switches from positive to, and then f of x is decreasing, where f prime of x is negative, so switches to negative. All right, so let's do an example. We're going to use the same function that we used for increasing and decreasing intervals notes. So find the relative extrema of f of x equals x cubed plus 2x squared minus 4x minus 8. Okay. So again, first step, you're going to take the derivative, but we've done this before, so you should be familiar with what the derivative is. So remember, I put directions in green. So take the derivative, and so we have f prime of x equals 3x squared plus 4x minus 4. We had already factored this previously, and so I'm going to go ahead and just write the factored form here. So you have f prime of x equals, and then the factored form, which was x plus 2 times 3x minus 2. And then we had set that equal to 0 and gotten x equals negative 2 and x equals 2/3. And what you'll do, same thing as before, as when you do increasing and decreasing intervals, is you're going to put it on the number line. And we tested the values in between earlier. So if you remember, we plugged in some number to the left of -2 to see what was going on to the left of -2, and we plugged in -3, and we got a positive number. We got positive like 8. And so if this is positive, we know it's increasing over here. Then we plugged in 0 over here, and we got a negative. And so this is negative over here. And then we plugged in something like 1, because 1 is greater than 2/3. So you plug in 1, and we got something like 3. And so that was a positive, and so this was positive over here. Okay, and so you can see here that we're switching from positive to negative. So f prime is switching from positive, so positive, where f of x is increasing, to negative. So f prime of x is negative, where f of x is decreasing. And then at 2/3, we're switching from negative, so a negative f prime of x, to a positive f prime of x, meaning we're switching from decreasing to increasing. So over here at x equals -2, we're going to have a relative maximum. And here at 2/3, we're going to have a relative minimum. And so you can plug into the calculator these x values so you can find the original y values. You want to do that to the original function because you're trying to find y values. So you plug that into your original function. So the original function is going to be x cubed. So we do x to the power of 3 plus 2x squared minus 4x minus 8. Okay, so we press graph. And then if you press trace, and you press -2, gets you a y value of 0, so -2, 0. And then we plug in 2/3, and we get y equals -9.481. Okay, so -9.481. And so at this point, there's a relative maximum, and our justification, since we're in calculus, you have to use the derivative, our relative maximum, because f prime of x switches from, and the relative maximum is switches from positive to negative at x equals -2. And then over here, we have this point is a relative minimum because, again, f prime of x switches from negative to positive at x equals 2/3. Okay, so we have found our relative max and relative minimum for this function, and we've included justification. So we now know how to find relative max and relative mins algebraically, and we know how to justify them. So go ahead and do some practice problems. Happy day!